Okay. So I guess the last thing is that when we have inequalities, right? So if we have a system of inequalities, because we could have a system of equations or a system of inequalities, I guess the only thing is that with an inequality, there's it's not just one answer, but there's a couple different answers that could work in the system, right? And so how do we decide what answers those are, or what possible region of answers, I guess I could say. And that's where we would probably do best to graph them, right? So just a quick review about graphing inequalities. Okay. When we have these symbols, so the greater than or less than or equal to, we're going to have a solid line, right? And the solid line means that we're including the answers that are on the line. Whenever we have regular inequalities like this one, we're going to have a dotted line, right? If you guys remember that, we used to have like lines like this, and that basically tells us that we're not going to include anything that is on that line. And then we got y. When we compare them, if we see that y is greater than x, and then we could say that the shading, we need to shade the top part of the line, right? And if y is less than x, then we need to shade the bottom. Okay. Again, this is all review from Algebra 1. We kind of, I don't know if you guys remember that we sort of did like a little mini like treasure hunt with the classroom. Okay. So let me go into an actual graph so that we can do an example. And let's see. Just give me a second while I pull up the graph. I probably should have done this beforehand. Okay. So we have our graph here. And we have y. So we have y is greater than or equal to x plus 5. And we have y is less than or equal to x minus 4. So this is our system right here. Okay. So let's try to see the first one. We're going to do it in red. Okay. So all it is just, okay, the y-intercept up here is 5, and you can use like decimals or some like graphing like application or anything like that. That's fine. Doesn't really matter. But we come up here and the slope is 1, so it should look something like this. Now remember that this is going to be a solid line because of the inequality, right? But comparing it, where would the shading go, on the top or on the bottom? Anyone?
The top.
Right. The shading would go up here because y is greater than x, so shading goes on top. Now with the other one, let me do that in a different color. We have -4. The same thing here. We actually it's actually a slope of 1. And what about this one? Where does the shading go?
The bottom.
This one, the shading goes on the bottom. Yes. Okay. Now, this is an example where maybe they don't meet. And the reason why is because of the parallel lines, right? They both have the same slope, so they're both parallel lines. So there might not be a solution that works with this system, but we do have solutions that work with the individual equations, right? This is just sort of like a little review on actually graphing this stuff. But now let's do an actual system where they probably will meet. So now let's say I have y is greater than negative 1/4 x minus 6. And then I have y is less than 4/3 x plus 5. Okay. So again, you can use a graphing software like Decimals or anything. We go up. I'm going to start with the bottom one in red. Comes up here. And is this going to be a solid or a dotted line?
Dotted.
Dotted, right? Yeah. Because of the inequalities, you should see that it's a dotted line. So I don't know. It ends up looking something like 2, 3, 4, 1, 2, 3, somewhere around here, like that. It's a little crazy, but yeah. There we go. Something like that. And then the shading for this one should go on the bottom. So it should go all over here. Okay. Well, before I actually do the shading though, let's do the blue. We're gonna go down to -6. And this one actually has a negative slope, so it looks like it's gonna be down 1, 1, 2, 3, 4. 1, 1, 2, 3, 4. So it looks something like this. Okay. And the shading for this one goes on top. Okay. Now, the idea here is that there's going to be a part where both of the shading for the red line and the shading for the blue line should sort of meet up, right? So where do you guys think that would be? And I don't know if for those of you that knew how to draw on the actual graph, I don't know if you guys can do that right now and try it out. So like, where do you guys think it would go?
It's not letting me draw, sir.
Oh, it's not?
Nope. I got one dot in and then I said nope.
Oh, there you go, Lindsay.
Good job, Lindsay.
Yeah, so Lindsay, right where you're putting it, right? In that area, because, and I'm gonna do this, I guess, in purple because red and blue. The blue line, yes, has shading on the top, and the red line has shading on the bottom. And there's gonna be a point where they meet up right where Lindsay is doing all scribbles.
It's working, sir. I can draw now.
Oh, and Desi as well. There we go. So yeah, that whole area. So we can literally go into that and pick out a point out of that region that should work as a solution for this equation, right? So, well, kind of hard to see now, but what kind of point do you guys see that maybe could work as a solution? I mean, there's plenty of in there, but as long as it's in the shading, what kind of point? And it could literally be anything, right?
Like any number?
Yeah, like any point, right? So like, for example, the origin is in there, right? So 0 and 0 would actually work, right? What about 1 and 1 is in there? That would work as well. 1 and -1, there's very different ones, right? There's all kinds.
What about 4 and 1?
4 and 1 works, right? It's in there.
Like -3 and 2.
-3 and 2 should work, right? as long as it doesn't fit in the line, right? So for example, if I were to get the y-intercept, which is 0 and 6, or sorry, 0 and 5, that wouldn't work because it's actually on the line, right? So if it's on the line, since it's a dotted line, it wouldn't work, right? But if it was a solid line, then it would work because we're including it, okay? All right, one more example. I'm gonna clear all the drawings. One more example here. We do y is negative 2x plus 2, and y is 2 over 3x minus 2.
So the
Okay.
line would be solid.
Right, so both of the lines would be solid.
Sir, how many questions are going to be on our test?
I'm not sure. I haven't done it yet. I don't think it should be very many.
So you should make it like maybe like 5.
I mean, it's possible. It's just that like the only thing with having so little is that you get one wrong, and it's like.
Oh, okay. Yeah, make it like a 10 questions.
Yeah, I think somewhere around there should be okay. I remember. I mean, I still take those as a star scale. So as long as you're like, I guess mastering, that should be an 8, right? And I think mastering is like what, like a 70% or something, somewhere around there. Yeah. Don't worry. I think I mean, I think they should be pretty simple, guys, because I think we've been doing pretty well with the systems. In 2 variables, writing actual systems down.
Wait, you're not gonna put what we just learned on there, are you? With the 3 variable thing?
Maybe not, because we don't have the calculators.
Okay, because I do not understand that.
Mm-hmm.
Sir, I swear if you do, me and Lindsay will find you.
For real. Sir, I'm still having trouble doing that problem.
Uh-huh.
Poor Asia got kicked out.
Let's see. Yeah, I might not.
Sir, I might like.
Calculators.
Oh, okay. Sir, well, I might get kicked out like every now and then, but I'll get back in. It's just my Wi-Fi sucks, and I'm out here making noodles. So.
All right. But yeah, don't worry. I think I'll just the only thing would be like maybe like regular 2 variable systems that we can solve. Yeah. But anyways, let me just do this last one. It says 2 over 3x minus 2. Okay, so it looks like 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. Okay, so it looks something like that. It's a solid line. So actually, you know what? Kind of got my notes wrong here. This is actually not equal to. So this would actually be a dotted line. There we go, dotted line. Okay, and the other one would be in blue plus 2, and that has a negative slope, so that's 2 and then 1 right there. 1, 2, and then 1. Okay, and this one will be a solid line. Okay, so let's see. The shading for the blue line would actually be on the bottom. Oh my gosh, why does it keep doing that? The shading for the blue line is right here on the bottom. That is crazy. The shading for the red line would be on the top, right? But the place where they meet would be right here, right? So you can see the other shading where it's at, right? You can see where the blue line, where the shading of the blue line goes and the shading of the red line goes. And then where they meet is the purple part, right? So that would be the region where we would find a solution that works for both systems, right? So as an example, -3 and 1 could be in there. -10 and 9, for example, is probably all the way over here, but that works. Even the origin is still in there, so 0 and 0 would work. -1 and 1, anything like that. And again, as long as it's not on the actual line. So for example, I see that possibly negative, it was 1, 2, 3, -4 and -5. That is actually on the line over here, but that's since that's a dotted line, that wouldn't work. But as in another example, what about 1 and 0? 1 and 0 is on the solid line. That could work because it's on a solid line, and therefore we include that answer. Okay. So not too difficult, right? Again, it's pretty much a